Thank you for coming. Thanks. I'll give you this is going to be quite short presentation, but hopefully you'll be able to get something out of it, especially if you haven't understood or where memory places in the edge. Everyone's talking about the edge and a lot of new developments that's happening. And of course, Micron is really engaged with a lot of different customers associated with the edge. So if you think about different hype ideas that became transformational, many technologies like Netflix, if you're familiar with Netflix, they sent out DVDs and stuff, but it started that idea of on-demand. It started the idea of streaming massive amount of data. It started the idea of a as-a-service business model. In Pokemon Go, it was a really fun idea for the kids. But if you think about it, how augmented reality was incorporated into our world and the virtualization of stuff that it created. And of course, in industrial IoT or Industry 4.0, that was a great buzzword, but a lot of the industry didn't know what to do with it. It was just a terminology. It was a concept. It was an idea of putting together a digital image of the machine and digital representation. So cyber-physical systems, digital twin, and the industrial edge. Those are all new terminologies that are coming out with new technologies and solutions. So if you look at an edge infrastructure, you can't just do a sensor to cloud directly kind of solution. It's kind of limiting. First off, is the cloud interface is quite expensive because they charge you by the megabyte. And also it's not in real time. So it's very complicated to just send a stream of data to the cloud and then get it back in real time. The other thing is that you're always limited by how many sensors you can stick in. And so there's all of these things that you have to deal with. When you're looking at the edge structure, you need to include appliances or new devices that are going to host some of your cloud functions. So as you know from an Azure or AWS cloud, that they have edge-related software infrastructure just so that they can support the edge. But if you look at the types of devices and solutions at the edge, there are common paradigms or common concepts of technology that are associated with the edge. Virtualization, distributed architecture, multi-tenancy, X as a service, all of these concepts are common within all of the different solutions, either in a connectivity perspective, so how 5G, for example, is going to be structured, and how the IoT platforms are going to get distributed as well. So all of these common technologies are going to be used. So when you look at those new appliances that's going to come out at the edge, one of the things you have to consider is the different workloads that it has to come up with. If you look at a simple gateway used to be a protocol translator or a data aggregator, and that was the only thing it did because it was transferring stuff to the cloud. But if you look at edge appliances now that are all coming up, you'll see all the new edge appliances at the trade show. All of them are going to have to support new compute demands. They're going to need to have their own databases and own historians all within that same edge device. And then you should, then of course, in terms of like where that data is going to get stored, has to be also at those edge appliances. So all the boxes that you're going to see at the show and the embedded show, they're all going to have higher compute, higher storage, faster memory, all part of the infrastructure. Because they have to accommodate the new software that's going to be put in those appliances. So if you break it down in terms of functionality of an edge device, it can't just be a protocol translator or something that you send out to the cloud. It has to have that all of the elements that you see end to end, which is obviously you need security built in. You need to be able to aggregate data with time functions. So when I talk about time function, it means that if you're trying to, if you're just taking sensors of people walking by, it's not really time sensitive. But if you're trying to get the machine throughput or try to figure out the predictive maintenance of a machine, you're going to have to get data with time function. And so that's very critical as well. Obviously, you need the edge analytics and compute. When you look at the edge functions, you got to go from secure connection and secure hardware all the way to, like I said, the data aggregation with time function, edge analysis, and the local historian. So all of these elements are needed for every edge device. So every box out there is going to have to go through these elements for an edge function. From a memory perspective, these are where things that you need to consider if you're selecting a memory. So for example, on the secure and unique identity, we have Authenta. That's a very unique solution that provides you that unique identity and also a provisioning mechanism that is very secure. And secondly, in terms of high endurance storage, leading interface standards, high performance bus width, as well as intelligent partitioning. So some of our devices, for example, in some SSDs, they actually have what they call SRIOV. So they have a partitioning mechanism that allows for different virtual machines to be hosted within those specific SSDs. So it's very good for kind of these high-end edge compute applications. And of course, industrial focused portfolio. So from our perspective in the embedded business group, we do have industrial grade parts, higher temperature, and tested for industrial use cases. So if you think about all the different kinds of products that you're going to need, you need a full portfolio of devices from a NAND technology, NOR technology, as well as DRAM technology, right? So from a secure NAND and NOR, which is what the Authenta can offer, and then we've got micro SD cards. Some of them are very specific to a video surveillance or video streaming, so 24/7 recording, fast recording in video. And then obviously we've got other devices, the eMMCs, the NAND eMCPs, and of course our LP DRAM. So you got to go to a company that supports all of these technologies. So a lot of other companies, they're more focused on one technology versus another. But if you're really creating an edge platform, you're going to need all of those technologies to make it work. So why is there a race to the edge? So I think you know it. If you're the audience here, you know why you want to build new products for the edge. The whole show is all about building AI, building better compute and storage all within the edge, being able to support these cloud platforms on premise, the distributed architecture of the 5G RAN or new Ethernet technologies. They're all part of that new wave of products, right? And there is a race to the edge because all of you guys are needing to figure out what is an edge strategy, what is our edge strategy. There was actually a study by Microsoft saying that there was 80% of companies actually have an edge strategy, either through the software side, a hardware side, or services side. They all have a strategy. So it's important for you to consider as well that you have to have an edge strategy for your solution. So if you look at let's just focus on the DRAM technology for now. The DRAM technology has to catch up with the different kinds of cores that are coming up. If you look at the processors at the show, most of them will have multi-core architectures. So these multi-core architectures are going to need higher and higher compute, not just for the total processor, but for each core, it's going to require some level of bandwidth and data transfer. And so each CPU core, if you look at this chart right here, the system bandwidth is all going up, and the core counts are going up, but the bandwidth per core, which is your memory interface, remains the same. So what do we have to do as a memory company is we have to go to the next level of DRAM technology to support a faster throughput with this, to support all of these new processors. So, if you go from a DDR4 to a DDR5, you can see here just an example. They're both running at 3,200 megasamples per second, and this DDR5 gives you 1.36 increase in performance. If you look at a DDR5 running at 4800, then you go from almost twice the speed that you can get to that same device. So it's obviously for Micron, it's very important for us to be at the leading edge of these technologies, because the processors, as new processors are coming in, new ASICs are coming in, all of these have some AI accelerator or some kind of higher compute requirements. Then the DRAM also has to follow as well. So obviously, we not just sell the chips, we also have a great portfolio, a full portfolio of DRAM modules to support all of the different kinds of compute engines. So we were talking about DRAM modules from just the overall compute and whatnot. But for AI-specific related solutions and applications, there's always going to be a higher speed requirement, or also in terms of power requirements for these compute engines, because they're going to be on-premise. You don't want you can't put them in an air-conditioned rack in a data center or that kind of thing. It has to be an industrial grade part. So an LP4 is one of the go-to technologies or memory technologies for AI-enabled devices. So and the reason is because you'll see how the performance of LP4 and LP5 is growing, and when you get to LP5, it's almost 50% faster throughput that you can get out of LP5. At the same time, LP5 technology is also going to reduce your power consumption almost up to 80%. So these are very good indications of what kind of new technologies you can support with either new GPUs that are coming up, new ASICs that have the accelerator, and new processors that have the accelerators built in. So we're seeing, even from our customer perspective, we're seeing LP4 and LP5, LP5X as solutions for AI-enabled chipsets and solutions. So obviously, Micron has a full portfolio of LP DRAM. We're actually the first ones who first to market with a functional safety certified LP5. I mean, it's functional safety for automotive use cases, but it just tells you the level of rigor and quality that we provide. I mean, if it passes automotive use cases, then certainly for a lot of different applications, it'll also support different kinds of LP solutions as well. So the other side of the spectrum, we talked about DRAM a little bit. We also have different kinds of SSDs and storage devices, right? So we have some embedded ones that are M.2 and the smaller ones that you could do with a wider temperature range. But this is one of the newest ones that we've got. It's called the 7450 SSD, and these are more data center-like, or data center level. But because of the range of density and the performance, it actually can support a lot of industrial use cases as well, from a kind of a micro data center use case. And so this is one of our latest solutions that we've got. It supports that 176-layer CMOS technology. It has a very high-level QoS, as well as the capacity goes up to 15 terabytes for that one device. Okay. And so, just in conclusion, just to let you know, again, if you're creating an edge solution or any kind of edge solution that you have to look at the full range of edge function, from the security all the way to AI, the data aggregation with time function, and the support for the cloud interfaces. And Micron is one of the leading companies to support pretty much all of the memory technology needed for any edge solution.